So now what we're going to do is do a chalk talk on how we make TMT happen. And as he mentioned, and I'm going to reiterate, there are no drivers or agents on his laptop. There are no drivers or agents on the file server that we use to move the data. We are not in front of the hot data, and as you saw, everything was native. So how did we make that happen? And that's what Mike is going to talk about. Mike is our CTO at Komprise. He's also one of the co-founders, and he's going to show you how we make all of this magic really to happen. And again, one thing I want to bring up, everything that we've just shown you is something that really is distinct and different, what separates us from a lot of the other data management solutions that are out there. So with that, Mike.
Sounds good. Mike Peercy, CTO and co-founder at Komprise, and I'm excited to tell you about TMT, which is the technology, one of the technologies and the core technology that we brought together with Komprise. So those who know Komprise know that we move, we archive, we tier data from your primary NASs, and NFS or SMB, to some other storage of your choice. And in this case, we'll just go with a cloud object store. And we call the primary storage the source, and we call the object store, or wherever it is that we're writing, the target.
Mike, one question. Can you support multiple object stores? Could you have some of your data sitting on Azure or some of your data sitting on AWS, or does it always have to be the same object store?
No, absolutely. That target can be Azure, can be AWS, it can be Google Cloud, it can be Wasabi, it can be even another NAS. So if you have a less expensive NAS that you want to tier a more expensive NAS data to,
all of which can be concurrently. So I could have all those clouds active with some portion of the data.
Yeah, each individual source share can go to any target of your choice. So you can just spread them out as you wish.
All right, thanks.
So the main reason you want to do this is for cost reduction. You want to take the less access data off the source and put it on the target. Well, this problem's been around there for a while. And there are a number of different approaches that can be taken. One is you can go ahead and move all data all cold data straight from a source to a secondary storage. But what this does is, one thing has to be like to like. If I've got NFS, I've got to move it to NFS. Another thing is it now disrupts the users and the applications, because now they don't find the files where they expected them. They have new processes to know where to go and look for the files. Another way could be, instead of moving files, we move blocks. So you take cold blocks or blocks of cold files and move those to the target, and then let the file system take care of that. But that is proprietary. It's more like it's inside the filer, and then the blocks, when they arrive at whatever this target is, are not really native to the target. They're not really usable on target. Another way to do it would be stubs. So you could stub out the files here, move the files, leave stubs behind. But again, that's proprietary, often requires agents or other databases, all kinds of stuff like that. Another way would be symbolic links. So you could just put a symbolic link here, which is a file system construct understood by the file server, understood by client file systems. And then you could move files and leave a link behind. But in that case, again, it would be like to like, NFS to NFS, SMB to SMB. And then these links would be very static. It would bind those two pieces of storage together, and you kind of have the same problem, just a little bigger, because you've now got it in two storages. So at Komprise, we looked at, how do we want to solve this? How we face this problem? How can we solve this problem? And the solution we came up with was TMT, Transparent Move Technology. And what Transparent Move Technology is essentially transparently extending the source share into a target of your choice. So your source share, we just take the cold data from that source share, put it in the target of your choice, here just cloud object, and we transparently extend that source. So we actually have added volume to the source. We've taken data off, but we essentially have made this more bottomless, because now we can add more hot storage on top, and we bring this down and transparently extend it to the target. And at the same time, We provide complete fidelity of the files from the source that we have moved to the target. And I'll go into the details of that. So how do we do that with TMT exactly? Well, when we move one of the files, we leave behind a comprised dynamic link. And so in this case, we move the file over to this target. Over in the target, it's just an object, as you saw in the demo. But here, it's a comprised data link, and as you saw in the demo, if you want to look at it through a file browser, it does look different. It is a symbolic link, which again is a native construct of the file system, but it's not a static symbolic link. It's a dynamic symbolic link, and it doesn't refer to some other piece of storage. It refers to the comprise access address, which is hosted by, as you heard in the demo, is hosted by an observer or one of a number of observers. And the observer is the virtual appliance, or it can be put on hard metal if needed, but it's the virtual appliance that serves as Komprise's workhorse inside the data center near the storage. And it hosts network file system interface the same way as the source share as the file server does. But behind that interface is what we call the Komprise Cloud File System. And the Komprise Cloud File System is what recognizes the target data, the data that's been copied to the target, and then wraps it up so that it looks like the source data, and that we can pull things from the target with perfect fidelity. So I can show an example of that with a user access. So we'll have a user at the source with a laptop or whatever others, or it could be an application too. Now the first thing to recognize is that when the user wants to access files on the source, they almost always, just about every time, want to access one of the files at the source that's still hot. One of the files that hasn't been accessed, that has been accessed in the last year or the last month or the last week. So there could be a number of these files in the source that are hot. So while we may have taken 70% of the files and moved them to the target, 30% of the files after our first motion on that source are going to be hot files. And when the user accesses those, they of course just get the file directly back from the file server, right from the share. All of that is handled by the file server, which you bought to be performant. Your reason you're tiering is because it's expensive. So we're letting the expensive hardware, the high performance hardware, do what it should be doing. Komprise is nowhere in that picture, as you've heard before. Now, in the event that the user wants to access a file that has been archived away, then they come in, their file system on their computer accesses the Komprise dynamic link. And then the client file system redirects to that Komprise access address, and KCFS recognizes and dereferences that link that it received, and then pulls the file from the target, and then responds with, and then wraps it up so it looks exactly like the file did at the original source, with the original source metadata, the original source data, and gives it back to that user. So the user accessing the original source share sees exactly what they would have seen from the original source share had that file not been moved. We really have extended this source share into the target and then left volume over in the source so that you can now expand, put more hot data in that source and not have to buy another source.
Excuse me, I have a question here about so the NFS SMB that you are putting on top of the observer, right? So in the moment I have, for example, a cyber attack like a ransomware, and so my files are encrypted, but if the attack is intelligent enough to go directly and fetching the file? Can I encrypt the files that you are storing also in the... I mean, how resilient from cyber attack or any other security issue is this NFS SMB share? Because you are providing access to the same files that I have locally.
Yeah, so we do provide the mechanism for encryption, end-to-end encryption, where KCFS itself will encrypt the files before it sends them to the target. So if you were to try and get to the file at the target, it would be encrypted. If that is the
yeah, but I'm accessing from the front end, which is the NFS.
Yeah, I think to protect that, you could also use because we're not storing the data at the end, right? The storage is let's say S3, right? So there are S3 object locks and all that stuff capability available. That's like for any storage environment, right? You have to protect the data at the storage level as well, right? So that's really, we kind of support those protection mechanism where you could have the object locking enabled on the S3 so that, hey, your data is protected even though someone tried to kind of overwrite it. You could also provide just read-only access to the data of the cold data through Komprise, so no writes are allowed at all, whether you want it or not, basically, right? So there are kind of different level of mechanisms we have to protect that data.
Yeah, but if a user access the data, which is provided by this other file share, which is yours, and I want to write the data, so I read a file that is 1 year old, and then I want to write in that file again, what happens?
Yeah, so you could enable writes, but you can protect the data, original data, by and when the S3 object locking, all it does is it just creates the versioning of the data in the cloud, right? So you still have the older version of your object sitting there, so you can kind of recover if there is a ransomware attack.
Okay, but it's not automatic. I mean, the versioning, it's managed by the object store.
It's the object store support of versioning, that's right, yeah.
So it's a
we recommend customers to enable it so they have the previous version of the data, yeah.
Yeah, but then there is a manual operation to recover my data. Because I have the versions, but if your solution doesn't manage the version in the front end, I don't have, the ability.
Yeah, you from the object store, you got to go roll back to the previous versions. Yeah, that's right. Yeah.
Okay, very good.
So when you access the data and the archive data, are you fetching the data from the cloud and reinstituting it at the observer, or are you just doing a pass through to the data on the cloud?
We are bringing it in from the target, depending on its form, it can be native here, it can be block here. We are putting it back together and streaming it back out. Yeah, so it's whatever is the most efficient way to bring it there, and we do in fact cache data underneath the KCFS layer when it's needed if we're expecting more accesses. And then as far as returning it to the source share, we allow you to set access policies. So if a file has been accessed so many times in so many days, then we'll go ahead and the next time we get it, we'll go ahead and replace that link back with the file that keeps getting accessed.
And the high availability characteristic here that Mohit mentioned is because there's multiple observers?
Exactly. So I'll just skip ahead here and show that characteristic. The observers, this is one observer, but the observers can operate in a grid of observers. So each one, and it just scales right out. You just add new observers in. You point them at the director. They're recognized together as a cluster that works together, that saves state together. They load balance the shares across them, so all the work that's being done is load balanced across. They load balance the shares that are held onto by KCFS, and the Komprise access address rotates among them to the one that is the most appropriate at the time. So if one of them fails, the others recognize that failure, they pick up the Komprise access address, so you have both high availability of this access address as well as scale in all of the operations we have to do as the number of shares and the number of files increases.
And there would be multiple NASs in this environment potentially as well, all accessing the grid of observers at the same time. There wouldn't be a separate grid for a separate NAS or anything like that.
No. So each NAS, there could be hundreds or thousands of source shares on dozens of filers, and the observers would be configured with them. You saw the analysis and the setup, where the director knows what the shares are in this site, and then points the observers at them, and then they balance those shares among each other. So yeah, there are rules for scaling and how many of these observers you should have in a grid.
All right, thanks.
So to go back to access, I mean, we looked at how someone wanted to access the source share. They would essentially see an extension of that source share on the target. But you could also have users who are interested in the data on the target, or applications that are interested in the data on the target. They go and access the file at the target, which is an object in the target, natively in the target. So exactly the file that was over here, the file data, it appears in the target and can be accessed by applications and users in the target. Now, and as I said before, this target doesn't have to be cloud. It doesn't have to be Amazon. It can be any cloud object store, any on-prem object store, or NFS or SMB. So if you have an SMB source, you can even have a target that is an NFS target, and that the SMB source will be reflected natively on the target as NFS, but when accessed through the Komprise dynamic link, it will come out and appear with its full fidelity, perfect fidelity of the original SMB file that was there.
Just a quick question in that case, for multi-use workloads, saying ingest on an NFS system that I want to run through an AI ML system in an object store, can I set up those jobs to actually duplicate the data?
So we can copy. So you saw the plan that in the demo. So the plan can do archiving, but the plan will also do copying. So you can completely copy this and leave the data on the source share. You can copy a whole share onto any target of your choice. So you can copy it up into the cloud and then natively see it there and work on it there.
Okay.
Yeah, sorry to interrupt. I have a question about the operational management of this. One of the things that makes me nervous is I dealt with some of these systems 10, 15 years ago. They're a little bit fraught. I'm interested in the failure modes of the insertion part that you're doing, because you're doing some kind of magical stuff to make this work, which is tremendous. And the fact that it does actually replicate data to the target gives me a bit of comfort that I've got a way of getting at my data if something horrible goes wrong. What kinds of failure modes have you observed where you're inserting this mechanism in line? If it goes badly, what can I do to get myself back? But sometimes computers are terrible and they break. I'm hoping this is not likely, but if it does, how do you deal with that sort of rare event when it does? Because this is often important data.
Yeah, so everything, the first point, it is a great question. The first point is that these observers, these virtual appliances, are completely stateless. If they all vanished, the only thing that would happen is they would take the credentials that were stored on them away. And you just bring in new observers, point them at the director, add the credentials back for that target, because we don't have the director store these credentials. Add the credentials back for your targets, and immediately those new observers would set this whole system up and would work. So that's the first thing, is that all the data that we're talking about here is stored on that target. And then algorithmically, the way that we handle the moves, the way we do it very securely, we do it with very clever algorithms to make sure that we're not going to lose any data or lose any metadata on the way to the target. But the big thing is everything that needs to be persisted is persisted on the target, or just in the state or configuration.
Okay, cool.
Thanks. So to go back into just to show what the final bits of magic here. There's this big box in the observer, and you heard in the demo that the observer does a lot more than than managing TMT, managing the transparent move technology. There's also, each of these observers hosts a transfer engine. And it's that transfer engine on each observer that actually does the move of the files from the source to the target. And that replaces the file with the Komprise dynamic link. And then whenever there's a recall, as you heard, after a number of recalls, there might be an automatic recall, or we have the capacity to ask for a bulk recall. I need this entire share or just this directory from the share recalled. Then the transfer engine will do that as well. But along with this transfer engine is the analytics engine, and the transfer engine also does the migration, it does the replication, it does copy, it does moving while not leaving links behind, etc. A whole host of functionalities that you can command through the director or through APIs are then handled by the transfer engine.
So that data lake is done at the observers, or is it done at the director, or is it done in combination of those two? And where's the metadata in the solution? Obviously, it needs to be in the object storage. It also kind of needs to be in the observers, but it's stateless, so it needs to be in multiple places.
Yeah, those are excellent questions. I should pull another color, but I'll use blue. I'll use blue here for this one. But yeah, so we're asking where does the metadata exist? Well, the metadata for the files is saved on the target. So again, everything that you need to reconstruct these files is on the target. The observer just has the intelligence to do it. The metadata that goes into the data lake is recognized by the observers as they do analysis, but they just, let's do purple. They do, they immediately send the data that is determined from analysis. They do the observations, they build up the aggregate analysis that you saw on the plan page, for instance. But the detailed analysis, the per file analysis that goes into the data lake, those observations are sent directly to the data lake, the Elasticsearch database behind deep analytics. And that could be on-prem if you're security conscious, or it could be in the cloud. It's a service run by us that then our directors can query and our observers can query, but the actual insertion of the metadata for each of the files comes from the observers as they recognize that data.
So the directors don't necessarily have access to metadata unless somebody's doing some analytics on it.
Right. You can run queries through the director to get that metadata, and then some of the queries that you can run through the director will pull more of the metadata. So you can enumerate all the metadata of all the files, and that could be done from the director. But the director, as you saw, the director's often up in the cloud as a service next to that, or on-prem, there would be the deep analytics database and system would be next to the director.
All right, thanks.
So we can step back and see what we've done here, see what TMT allows us. So the first thing that we see is that the vast majority of accesses are to hot data, and we're not, the Komprise TMT is not in the picture when we're accessing hot data. But but we've taken the cold data off, which is not the majority of accesses, it's almost no accesses, but it is the majority of data on that source share. We've taken that off and put it on less expensive storage, while at the same time transparently extending that source share so that a view of that source share, when all the users who come to the source share see the data as though it were still on that source share. And we've now placed the data in the target in a native way such that users on the target, users can go straight to the target natively and see the data on the target. So we've reduced costs with no user disruption while providing new uses and new accesses to the data.
I notice we only see those links created once the data has been moved, but I'm assuming obviously your observers have data on all the objects in all the systems. Is there any interest in trying to convert people to point directly to the observer structure instead of going through the legacy NFS share interfaces, for example? Can you expose that?
They can point directly to the observer infrastructure on the NFS and SMB. Yes. So, for instance, when we're doing copy, so we're not doing the transparent archive, but we're doing copy of the source share. That is the way you access it. It's going straight to the Komprise access address.
Okay. So it shows up. It shows up as another share that we can access directly, and then it redirects as appropriate to the object store at the backend.
Exactly. KCFS, the Komprise Cloud File System, pulls those and puts that data together. So it looks like the NFS SMB that was originally copied there.
Okay, even though I'm not talking to my original NAS. Good.
Right.
Next steps, if you want to learn more about Komprise, please go to www.komprise.com. If you want to do a free trial, komprise.com/free trial. Would love to have you come and take a look at it. I think it's a way of addressing a fundamental problem that's out there.
Kumar, just one question. How's the licensing done? Is this done on capacity? Is it done on observers? Is it done on users? And that sort of thing.
Great question. It's based on how much data we manage, so capacity.
And the data managed would be even the hot data as well as the cold data, or just the cold data?
It's the data that we analyze. So therefore, it includes the hot data because we are providing you a data lake of all your data, hot and cold. And we're managing the data that's going continuously, making sure anything that we're archiving or copying and so forth, we're doing it continuously. So we are working on your entire data set. So it's on the total capacity.
All right. Thanks.
Okay. All right. Well, thank you very much. Really appreciate it. Good day.